And let's get going. Welcome everyone to our first in a series of outreach webinars designed for the commercial sector. We're very excited today to talk about the On-Site Energy Manager program, which is fabulous. I'm excited for Mike Madigan's presentation, and I won't spend too much time on introductions, but I did want to go through the usual webinar intro spiel. Mike will be presenting. It should take about 40 to 45 minutes. We anticipate a Q&A session afterwards. Please feel free to type into the chat your questions, and we will address them towards the end of the session. We'll also have contact information listed at the end of this if there's any interest in follow-up. And we will be recording this webinar and to make it available certainly to attendees if they want to go back and review at some later point, or to share with others who might be interested in the content. Without further ado, let me just introduce myself. I'm Bennett Sandler. I'm the campaign director for Heat Smart Mohawk Valley. We're a NYSERDA funded clean heating and cooling community campaign. We're one of 14 across New York State dedicated to advocating for clean energy and connecting building owners with the expertise and incentives to take steps towards our clean energy future. We're very excited to have Mike Madigan of Rombel, formerly O'Brien and Gear, which was an exceptionally well-known engineering firm in New York State and across the country, and is now part of a much larger family worldwide dedicated to bright ideas and sustainable change. So we're very excited that Mike's here to explain his project at Buffalo State College, which, as I've been informed, is the model for NYSERDA's On-Site Energy Manager program. And so I want to introduce Mike. He's been doing energy-related work since the 70s. He's a graduate of Clarkson University in mechanical engineering. He's a professional engineer, a certified energy manager, and has LEED accreditation as well. So all the appropriate alphabet soup to indicate that he knows what he's talking about, and we're really excited to have him here and to talk about this this program. So without further ado, Mike, please take it away.
Well, thanks, Bennett, and we really appreciate Heat Smart Mohawk Valley for hosting these seminars, and we hope that we're going to be watching as these continue to roll out. So we're going to be like Bennett says, the presentation will be about 45 minutes, and then we'll have time afterwards to respond to questions. If you think of questions along the way, put them in the chat. If you think of some at the end, we'll have time to catch up. And we're going to do, we're probably going to, it's set up to be an hour. We'll probably, stop the clock at an hour, but if there's questions that continue afterwards, we're willing to stick around if there's folks that still want some additional information. So I'm going to do the commercial portion of our talk here. So as Bennett said, we're formerly O'Brien and Gear. O'Brien and Gear became part of Rombel in January of 2019. So now we're part of a much larger world, and we've got 300 offices in 35 countries. And in the Americas alone, where we've got 2,000 employees, we've got 85 offices across 4 countries for a total of 16,500 employees. 15,000 are technical professionals worldwide, with 2,100 in the U.S. alone. So Rombel was founded in Denmark. Its organizational structure is a little different than most U.S. companies, in that it was founded by the Rombel Foundation, which means that our activities are independent of any external or personal interest. We are driven by the foundation. We have no ownership or financial ties to contractors or suppliers. So that's you know, we do a lot of social benefit type work. We try to stay above the fray from an organizational standpoint. And we've been involved in energy for the last 45 years, planning, design, implementation of energy solutions for the full spectrum of technologies. And we look at this as a holistic and multidisciplinary approach involving you know, end users, owners, and whatever goals, climate goals that that the public and private sector clients might have. And this project here, the on-hold offshore wind farm is one of is a Rambo project that was completed in 2013. It's the world's third largest offshore wind farm. It's 400 megawatts, placed in the Kattegat Strait between Jutland and the island of Anholt, and it produces energy equivalent to the annual energy consumption of 400,000 households, or 4% of Denmark's total power consumption. So. You know, as an engineer in the energy field, you know, we're excited to be part of this larger family that has projects like this in their portfolio. So our talk today, we're going to talk about first of all the barriers to effective energy management, which is kind of create the pathway to why an on-site energy manager makes sense. Drivers and mandates that run in the background that might create might create some incentive for pursuing this course, and the Buffalo State College Campus Energy Manager project, which we worked on. We'll talk about that in detail, including making the business case, which was the goal of that project. And in this as energy and HVAC engineers, you know, the current pandemic has changed the way that we do business at a business as usual, operations as usual. So we're going to talk about the impact of COVID-19 on campus energy use, and then we'll talk a little bit about the on-site energy management program, which is a way to get 75% funding for someone who's doing the sorts of things that I did at Buffalo State College. And one of the drivers is, you know, people you know might say, well, why do I need a campus energy manager? And we do a lot of plant-wide audits. And at a kickoff meeting for a recent energy audit for the world's largest plant that's part of the world's largest soft drink manufacturing company, question I always ask, of course, is there someone at the plant whose primary responsibility is energy management? And then the answer I got back from our client representative was, well, they said, well, everyone's responsible for energy management in their respective areas, right? Well, our takeaway from that was, well, really, that means really nobody's responsible. So that's really kind of, you know, the perspective that you have, and it's not uncommon and it's not wrong. It's just that the focus is typically elsewhere. But this is a plant that spends $7 million a year on electric and gas, and you would think it might be worth an investment if you could save, you know, 5 or 10% of that a year by having somebody who's actually, you know, watching over the operations in that area. So the sorts of barriers that we might have would be lack of in-house technical expertise on the part of the owner. Not someone who can speak the language and communicate to ownership and management about you know, what the opportunity is and what needs to be done, and how that can benefit the company, really to get energy initiatives started. Lack of energy consumption and demand data. There's often monthly billing data as the extent of the information that we have, and to do really energy management, we need more. We need energy at the building level, at the process level. We'd like to have 15-minute interval data so we can tell how energy in a building or a process changes over the course of the day. And then we also have to have some analytics and some means and methods for measuring results of our progress and our projects, and determining the cost savings. First of all, before we initiate a project, we can say what we think it's going to save, and then a way to measure and verify afterwards, so that we can actually demonstrate and prove that we did what we say we're going to do. So These are all things that make it difficult in this market, which is why on-site energy management and energy management in general is still probably not where it really ought to be in our mind for the benefit that it provides an organization. There's other barriers, might be awareness of incentives that could be applied to projects, internal competition for capital, particularly in a manufacturing environment. Process needs and investments always trump energy investments. Short payback requirements. There's if it doesn't pay for itself in 2 to 3 years, sometimes projects are basically not pursued. And then failure to recognize some of the non-energy benefits that result from energy projects, which is the renewal of aging energy systems and equipment. I mean, these systems are inefficient because they're old. They may be at the end of their useful life, and energy projects, in addition to providing year-over-year energy savings, they'll also renew the equipment, and now you've got sound operation and efficient operation for the next 10, 20, or 30 years with new equipment. So energy management requires constant attention to be effective, and it's been demonstrated to be an effective investment, which we'll show in some case study examples a little bit later in the presentation here. So our project at Buffalo State College, since the campus is a SUNY college and it's a New York State facility, it falls under New York State mandates and acts executed by Governor Cuomo, including Executive Order 166, which is the current state mandate. And that's reducing greenhouse gas emissions 40% by 2030 and 80% by 2050. Pretty lofty goals. New Efficiency New York is really another statewide initiative. The Climate Leadership and Community Protection Act, which calls for an 85% reduction in greenhouse gas by 2050 and a carbon-free electric grid by 2040. And we talk about greenhouse gas, and folks think about power plants and combustion sources, but really, when it comes to energy conservation, greenhouse gas emissions are reduced when you use less energy. So that's and it typically ends up being more cost effective than accomplishing the same reduction goals using renewable energy. Adding insulation and replacing outdated equipment is a lot less expensive than building solar installations and wind farms. So they've all got their place in the portfolio, but it's really the first step towards greenhouse gas reduction. And the other part of that is that you really need to have an efficient operation before you start implementing renewable energy projects, and because if your facility isn't efficient, you're going to be just wasting a portion of that high quality renewable energy that you just generated. So that's so those are the state drivers, and for private and institutional clients, there might be climate action plans that might create incentive to pay more attention to energy management, decarbonization goals, corporate sustainability projects, and initiatives, and private greenhouse gas reduction goals as well. And really what we're seeing more and more is a customer, community, investor, and partner demands for climate action and accountability when it comes to greenhouse gas. I mean, I think we're going to see that in the coming years, particularly with a potential change in administration. These priorities are going to find their way up in their national priority list, and they're already pretty high on the international list. So our project at Buffalo State College was really the purpose of the project was to demonstrate that a full-time campus energy manager staff position was cost effective, basically to make a case to campus administration that, geez, maybe we should to add this as a staff position. It sounded like the simple proposition, but it's this getting to that point started really back in 2013 when we did the campus energy master plan. And we did, there was one energy conservation measure 16, that we identified in the master plan. And that was the idea that an investment in a campus energy manager would have a positive cash flow. And we estimated that the cost savings would be approximately $381,000 a year. And that was, on paper, it looked like a good investment. So we presented that to NYSERDA and to the New York Power Authority, who was funding the Energy Master Plan. And they said, yeah, we think that's a good idea too. So we came up with a scope and an approach. We proposed a part-time position, and NYPA came through with $134,000 of funding. NYSERDA came through with $53,000, and then campus had a 25% match of $61,000, and that was for a 2-year pilot program, and for an on-site staff position working directly for Dan Hurd, who's the manager of energy and critical maintenance equipment. So that was approved. It began in January 2017. It was a 2-year program that was funded through the end of December 17th. It was part-time. It was me, 6 days per month on site. I did some off-site work, but most of the work was really on-site engagement with the campus. And once again, the goal is, using that engagement to make the case for a full-time position. As part of that, we were making reports to NYSERDA, reports to the administration, quarterly, what our progress was. And actually, if you look at the scope that we came up with, that was approved, that we wrote, and if you look at the reporting templates that we use, and then look at the NYSERDA on-site energy manager program opportunity notice, you'll see it's exactly the same. You see where they got the idea, I should say. So I'll talk a little bit about the audit. So there were 16 ECMs that were identified as part of the master plan, and 16 were energy measures, or like capital projects. 13 were low cost, no cost measures, but they really showed that the campus had opportunities for managing their energy better. So the scope that we came up with was to develop and implement campus energy projects. Number one, we've got to do stuff to save stuff. Evaluate and analyze campus energy use, and then achieve the 20% reduction in campus energy use intensity. EUI is the metric that was used for that, which is source kilowatt hours per square foot of floor area. And that was the goal of Executive Order 88. It's since been superseded by Executive Order 166. But this was the driver behind the project at the time we were there. Identify and coordinate energy incentive programs, and ultimately determine that a campus energy manager cost can be sustained through avoided annual energy expenditures. So our favorite quote when we look at energy management is, "To measure is to know. If you cannot measure it, you cannot improve it." And our William Thomson Lord Kelvin, 1824 to 1907, Irish mathematical physicist and engineer, quoted it, initiate that quote. It was true then, it's true today. Measurement, monitoring, analysis, that is the core to anything we do, and the more and the better detail that you have, the better. So when we first started the project at Buff State, we found that there were 43 electrical meter buildings. 38 were on the New York Energy Manager platform, which is an energy information system that uses campus level meter data through an online platform that logs and trends 15-minute electrical interval data, and that's available free to the campus through the New York Power Authority. So we were glad to have that, but when we started using it, we found that there were data gaps for many meters that weren't functioning, so we first of all, I had to install 5 new electrical meters to replace 5 that weren't functioning. And that process of validating and monitoring and keeping the meters, keeping them reporting, keeping the data, flowing, that's an ongoing effort that, when folks say that they really need metering, it's true, they need it, but they do need it. But getting there and then maintaining it it requires an effort. It requires somebody with some focus, which is the campus energy manager. So the New York Energy Manager is one platform. The other platform that the college has available to it is Energy Cap, and that's provided through SUNY. What that does is that they for Energy Cap. Utility billed information, monthly data is submitted and logged, and then it's available for analysis through another online platform. So there's 2 online platforms. Energy Cap has electrical and gas data that's monthly, but it's not at the building level. Okay, it's based on the meters, and there's one campus electrical meter, and there is several campus gas meters. So it's just for those individual utility accounts. New York Energy Manager is a much deeper dive that goes to the individual switchgear transformer locations at each building. So we can get building level data through New York Energy Manager, and we can get that both for consumption and for 15-minute demand, which gives us the capability of doing a deeper energy analysis. And that's we're going to talk a little bit later about the NYSERDA Real-Time Energy Manager program that's available with some funding underwriting, and that's really the purpose of that, is to provide data so that we're not doing our energy management in the dark. And the other part is we have this data, we can see how things are operating in real time. Now we can optimize HVAC and lighting operation controls through the building automation system. So, and that's really the key to low cost, no cost measures, because it doesn't cost anything to change a schedule. And the savings, the most cost effective savings is really saving energy that you don't use. That's the cheapest energy that that's the cheapest greenhouse gas reduction you can get, is not using energy that you don't need. So the other low cost measures that we looked at, in addition to HVAC equipment and scheduling, and if you look at the little graph there to the right, that's a New York Energy Manager graph for one of the buildings on campus. That was the Bulger Communications Center. And if you see that, the trend line is going along week by week. Every one of those little peaks is a weekday, and it goes into an unoccupied mode at night. When the campus was on winter recess, we reset all the equipment schedules. They didn't need to run when nobody was there, and you can see what happened to the energy use in the building. So this was a simple change to the building automation programming schedule, and the energy savings at zero cost is the difference between the peaks before and the peaks after. You can see we went from 150 kilowatts down to 50 kilowatts. So that was like 100 kilowatts of savings during that period, and that ended up being, obviously, pretty cost effective. If you could do this with all of your buildings during all of your unoccupied times, including nights, weekends, you can see the potential for savings. And then with the energy data like this, you can also do a calculation that tells you how much you saved when you did it. And lighting controls can be scheduled in a similar way. And we also reprogrammed some heat pump fans in a residential building that that was all heat pumps, the student apartment complex. And then some other low cost, no cost measures that we identified were compressed air leaks and been a repair to the solar photovoltaic inverter. So, so like I said, we use the New York Energy Manager interval data to determine what the individual system or piece of equipment was using as a baseline. And then when we make the change, we can see what it's doing afterwards, and then we can determine the difference, and that we can demonstrate that it actually that the change actually did what we thought it was going to do. So these are some of the examples of the projects. It's not complete and comprehensive. There were 25 projects that we did. These are just 5 of them, but I think that it sort of demonstrates what the what the potential is for having somebody on site. Even 6 days a month, you can accomplish some pretty impressive savings without a lot of investment outside of the energy manager's time, tracking things down and making them happen. So HVAC and lighting equipment scheduling, we talked about that. So that's $46,000 a year in annual savings. Okay, at zero cost. The Shut the Sash program was in the SAMC lab building, which were basically the labs. If you know anything about labs and institutional facilities, they basically run all the time, and the sashes are often open. So we implemented a program where the sashes were shut by the occupants. And when they were shut, we backed off the operation of the exhaust fans to accommodate the reduced demand in ventilation and exhaust that was required. So that project saved $37,000 a year. And we also did a number of interior and site lighting fixture retros. I say we. When I say we, I mean the campus. While we're the on-site energy manager, we are actually a staff position. There's a campus electrical engineer who actually did the lighting fixture retrofits. His name is Mike Carl. But we don't do this stuff in a silo. He's doing work. It's part of the energy program. We take credit for it, and we measure it, and we report it. So that's how we another way that we can justify the value of having somebody there who's paying attention to this stuff. And then steam traps, if they're not routinely tested and repaired or replaced, can be a huge source of wasted energy. At Buff State, we did a survey, or we had a contractor do a survey, and determined that replacing the failed traps would save $161,000 a year. So that program has been funded. It's sort of on hold now because of because of COVID, but the campus hasn't implemented the replacements yet, but they are planning to do that once business as usual resumes. And then the SAMC lab hood retro commissioning. I'm sorry, I forgot to turn off my phone. That was done by a commissioning authority, and basically similar to the Shut the Sash hood program. The hoods at SAMC were the face velocities of the hoods were reduced, and the air changes in the buildings were rescheduled based on occupancy. So that program saved $49,768 a year. So you can see these are 5 out of the 25 that we selected that contributed to the campus end result. So since January 2017, when the on-site energy management program started, the projects in total resulted in a cost savings of $330,329. The capital cost to implement those was $854,032, and the simple payback for that was 2.6 years. So that's and that reduced the energy use intensity of the campus, which was the goal, 13.5%, which gets them on their way towards their 20% goal under Executive Order 88. And this is really kind of the history of the energy usage during that time period when we were actively monitoring, managing, making adjustments to schedules, implementing projects. You can see the base year was 2016. You can see, so the combined cost was $3.2 million a year. In 2017. It went from 3.2 million to 2.9 million, savings of $339,000 a year, 10% of the campus energy. We would like to point to that, but we have to realize that it was a year where it was the weather was kind to us that year. So some of those savings were due to weather normalization. So the following year, there were twice as many cooling degree days, okay, which is how we measure the amount of the number of hours and days that you need to run cooling. So there were twice as many cooling days in 2018 as there were in 2017. And if you look at the difference in electrical use, you can see the increase was largely due to that. So we didn't see a net savings in 2018. However, when we look look at the 2 years combined, we still see a 4.78% cost savings over the 2-year program. So, part of this is, it's nice to look at things immediate, look at your bill versus your last bill. Really, these sorts of initiatives need to be looked at over a longer period of time. And other factors need to be taken into account other than just consumption and cost, because you can save energy and the cost might go up for a given utility commodity, and you need to track them both on your consumption and your cost. It's just the way that you track the metrics, and that's what a campus energy manager does. So making the business case. So at the end of 2 years. With those results, the campus administration, agreed that was a good investment. There was engagement, there was awareness, there was actions that were taken during that 2 years that Buffalo State College, agreed was, made good sense to continue. 4.8% average energy cost savings, combined for 2017 and 2018. And then probably most significantly, and this was really due to Dan Herr's efforts beginning in 2010, they secured $1.7 million in energy incentives for capital projects and maintenance projects at the campus. So they demonstrated that. The campus got approval to hire the position. But there was a change at the administrative level, and the full-time hire was put on hold. So since the end of 2018, beginning in January 2019, the Buff State has extended our engagement there for the same 6 days per month without NYPA funding or without NYSERDA funding. And we're still providing services at the campus. We're not there 6 days a month. We haven't been on site since March for obvious reasons, but we are still supporting the campus. There is still the intent that the full-time position is going to be filled, but at the present time, the campus's focus has shifted to some other areas. This has been, Dan Herr has been actively involved in these measures, directed by SUNY, the CDC, and ASHRAE, basically to provide safe operation of the campus when we've got COVID spread in the community. So And these are the initiatives that are mostly due to HVAC that impact campus energy use. Additional building square footage, because dormitories where dormitory density has been distributed between all of their available dormitories. They had some residence halls that were basically mothballed because they didn't need them. They had to open them back up to provide spacing for the residents that were on campus. Even though the campus enrollment is way down from last year, which is another loss in revenue, which is another story, but it's related. There was a requirement to increase fan efficiency, the MERV rating to MERV 13. That increases the horsepower required for the operation of the fans. That increases the energy use of the fans for every hour that they operate. Building HVAC needs to operate 2 hours before and 2 hours after an occupied period. That essentially added 4 hours per day of operation for every system. There was a requirement to maximize outdoor ventilation and minimize recirculation, which adds to heating and cooling energy for those airflows. Heat wheel energy recovery systems that contaminate air. Yeah, they have the potential for contaminating incoming air with exhaust air. Those have been discontinued, so we don't have that energy savings. And then in some areas where the central systems are insufficient, supplemental filtration units have been added, and the campus is expecting a 15 to 20% increase in HVAC costs, this year over last year when they didn't have to meet these requirements. So that's really the Buffalo State story. And as we said before, then I think a year or so after we started this project in 2017, NYSERDA came out with the Onsite Energy Manager program, and it's really, like I said, it's real similar to what we had talked about, although they're looking for a larger campus commitment. So energy managers are responsible for creating efficient processes that decrease cost and waste, and helping businesses achieve leaner operations. So a dedicated on-site energy manager can lower operational costs, reduce maintenance time, and create comfortable, safe facilities. So that's NYSERDA's pitch for the on-site energy manager. The highlights are it's a minimum 12-month engagement per facility. They're looking for at least a 0.5 full-time equivalent of staffing, which is 20 hours a week for that minimum 12-month period, but it could be longer. And then the position could be a new permanent hire or contracted staff through one of the NYSERDA technical consultants, of which Rambo is, of course. And to support this, NYSERDA provides a 75% cost share, not to exceed $200,000 if your annual energy spend is less than $1 million, and a 75%, if you're greater than $1 million, a 75% not to exceed $100,000 if you're less than $1 million of annual energy spend. And those applications will continue to be accepted through December 30th, 2022. So we're happy to see that. There's been quite amount of interest in this. The scope of work that's included in the NYSERDA opportunity notice for the campus energy managers, just like we were talking about for Buff State, develop and or maintain an energy tracking and monitoring system, identify savings opportunities, capital expenditures, O&M for further investigation, implement operational and preventative maintenance energy measures, investigate and secure available financial incentives and rebates, and track, measure, and verify energy savings results. So it's come up with a plan, identify the details, implement, get funding, and then really track your results. And that's, it's really kind of just that simple, but it's something that folks, even if they have the technical capabilities, if it's their facilities engineer or somebody in the accounting department or somebody in facilities operations and maintenance. Typically, we find that they don't have the time to focus on all these areas and do a job effectively. So it's really a project that it really can give you results that you wouldn't get another way. And there's some reporting requirements that are part of the program. There's monthly reporting, check-ins, reports to NYSERDA, which we actually did for the two-year program that we were involved with. And then there's a final report that's required, and a case study, savings metrics, and they like the facilities to come up with a 2-page online report. So these are these success stories. These are available on the NYSERDA website. You can see the link at the bottom, and I basically looked at each one. These are a pretty quick read, each of them. They're no more than 2 pages, but they identify the organizations involved, and there's 7 manufacturing facilities. There's 1 healthcare, that's Mount Sinai, and there's one municipal energy utility, which is Red Rochester. So, and just looking real quickly down the list, each organization had their own metrics, and that's fine. Everyone's got their own measure of what's important. But the Berry Global Group, they had $356,000 a year in utility cost savings. Burn Dairy in East Syracuse, 41 projects, $132,000 energy savings total. Corning Diesel, 4% energy use per unit of production. We like that metric because, it's not always important to use less if you're trying to make something, if you're trying to sell more. So keeping your metric as a unit of production makes a lot of sense if you have those metrics to compare. And Greenpack in Niagara Falls, they make liner board, cardboard liner board. Their metric was a 70% reduction in a kilowatt hour per ton of liner board. Gutchess Lumber, they had a 10% energy cost saving, and they also ended up with a $100,000 National Grid incentive. Mount Sinai Hospital, healthcare facilities are huge energy savers, and as an energy user, there's also waste built into the system. 1.5 million in annual savings costs. Red Rochester, 100 projects, 3.5% energy reduction, and then Pactive, 4% energy reduction per pound of product, and Xerox is 268,000 annual savings. So none of these are insignificant. I don't have the total of how many additional engagements NYSERDA has that weren't included in this report, but I think these 9 projects really demonstrate the effectiveness of it, and the fact that these companies were willing to put these together and share that savings. It tells me that they're pretty proud of the success as well. So that's NYSERDA OSEM. There's a the NYSERDA website has links to how that program how you can get on board with that. I think Bennett can help with that too. Is that right, Bennett? Bennett can be your pathway to getting.
Absolutely, happy to help anyone navigate NYSERDA's program.
So another program, and I don't want to spend an awful lot of time with this, but we talked about energy data, energy information systems. NYSERDA has a program called the Real-Time Energy Management Program, which is the next generation of building technologies. So you can learn how buildings perform in real time. You detect equipment faults. You can uncover opportunities to optimize energy use. So RTEM systems collect and monitor building systems performance data in real time using energy information systems, like we were just talking about for Buff State. And NYSERDA offers a 30% cost share incentive for real-time energy management. Project expenses, including 5 years of ongoing support from energy experts to help get the most out of these smart technologies, are eligible for a reimbursement. Industrial properties can receive up to $500,000 per site. Multifamily properties can receive up to $155,000 per site, and commercial properties can receive up to $200,000 per site under the real-time energy management program. It's complicated, but it's essential. If you don't have some sort of energy information system, you really, like Lord Kelvin says, you need to measure it if you're going to manage it. So this is the key to that. And with that, I will defer to questions.
Great.
Do we have any Bennett on the chat?
We do. There's several here that most of them are quite specific to some of the data and images that you presented.
Okay.
And I just want to insert one quick question. I'm sorry, and we'll get to these technical questions. If you sign up and take advantage of the NYSERDA Onsite Energy Management Program, since you're receiving funding from the state, what are the privacy issues around data sharing that a private entity may expect in terms of participating in this program?
So NYSERDA is very sensitive to customers' privacy concerns, and those that were those case studies that were shared were obviously vetted through the corporation's information offices before they're released. So no information is released without customer permission, specific customer permission.
Great. So let's get to the host of technical questions. Tom Kelly has several. The first one is going back to an early slide in which you were presenting actual data consumption at Buffalo State. He's curious why there was a 500 kW drop in demand between March 2012 and March 2013.
I'm trying to see.
I think it's farther back still.
Back. Oh, this one?
I think it was here, right?
March 2012 or March 2013. That's a good question. I'd have to go back to look at that.
Okay. So let's move on. Actually, his next question I think was actually answered by Rob. Buffalo State operates a district steam system, correct?
Correct.
And were there any gas measures that were installed during your tenure?
The gas outside the steam plant, there really is not much gas used outside of the commercial kitchen in the Campbell Student Union. The campus is undergoing a rehabilitation. Basically they're replacing their steam plant with a higher efficiency boilers than the old ones that are there. So that we didn't include that as a measure, but it certainly is part of the plant's energy portfolio. And when that's completed, it should be part of the reportings that goes through. But we weren't involved in that project specifically. That preceded us, and it actually construction is ongoing on that project.
A specific question related to the energy measures you covered in regards to COVID. Do you have any information specifically around, energy consumption due to, the increased measures, higher filtration and greater circulation schedules?
Yeah. So since all those changes in total, they end up being pretty granular when you get down to it. Each one has its own impact. To come up with what that is. I'm sorry, I missed it. You really got to look at every fan, every system, you could calculate it. Okay, there we go. So you could certainly calculate that impact that these in combination were, but we didn't do that. The campus didn't do that. We talked about it, but at this point, because there's really a lot of things going on now, it sort of is what it is what it is. We might not like that it's 15 to 20%, and I think our estimate, to be transparent here, I think our estimate internally to the campus was 15 to 20%. We think in reality it's going to be somewhat less than that, but we didn't want to sell it short because we didn't know, because there are some unknowns. There'd be quite a bit of calculation coming up with what that was, and right now we just wanted to set the bar and say yes, we should be prepared for some increases. And they're not going to be insignificant. So that was really the message, more than the actual value. It was, yeah, these things are going to have an impact.
It's going to add, right?
It's going to be in the direction that we're not happy with, but we have to do it. So
sure. So just as an aside, and I'll circle back to there's a couple other questions, but Tom, I just wanted to also mention that actually NYSERDA has actually a whole host of study programs that they're funding under their indoor air quality. I'll try and look up the URL when Mike starts back in with some other answers to technical questions. But NYSERDA has been funding, I don't know, 12 to 15 different flex tech consultants who are doing entire panels of energy studies related to response to COVID and indoor air quality measures, both filtration, or I should say filtration, increased ventilation, and UV stuff. So I will try and forward that, but there's a lot of work that's going on around what the energy, how do we do this and ensure occupant safety while also trying to minimize the penalty on energy. So I'll try and send that link, as I said. Actually, Tom also asked if there was any underground thermographic studies at Buff State to determine leaks in the distribution system. Sounds like they're expecting to replace it. Is that true, Steve?
Not the distribution, just the
Okay.
just the central, just the central.
Okay. So
And,
so the question stands. Any thermographic studies looking at distribution leaks?
No, but their maintenance of the underground is pretty good. And of course, your best thermographic is, in Buffalo is the ice melting.
Snow melt.
Is the snow melting. Right. There's a snow melt. You can, if there's a leak and there's excessive losses, it's pretty easy to find. You've either got water vapor from condensed steam, or you've got melted snow. So we haven't done anything beyond that.
Right. Andrea Geary from Tompkins County asks what energy models were used to model current energy consumption and projected ECM reductions.
So those every measure that we looked at as part of the Energy Master Plan had its own methodology for coming up with savings, and usually we'll use an Excel spreadsheet. Basically that puts the as-is conditions and then the proposed conditions to come up with a savings over whatever period that is. Where we have interval data, like we can get through New York Energy Manager, that allows us to benchmark really what our as-is condition with real consumption. We actually know what the use is beforehand, and then it allows us to, after the measure is completed, to look at what it's doing afterwards, and then prove the prove that it actually is working. So
great. I think there was one more in the chat. Hold on one second. I hid the chat from myself. Looks like I went to go share and I hid the chat from myself.
Yeah, it kind of caught me for a minute. What did I do?
Yeah, right. That wasn't you.
And I can read it. It looks like
Sure,
it might
Rob,
be Tom's.
please. Yep, it was Tom's.
Does Buff State participate in demand response? What strategies do you employ?
Haven't been participating in a demand response program, or I should say, there hasn't been an aggressive demand response program at Buff State. They haven't been called upon to participate.
So, anyone else have questions for Mike? Okay, we are sliding in with under the hour. Mike, thank you very much for your time. Folks who've attended, we very much appreciate your attention and interest in this topic. As I've mentioned, I will share with attendees a link to the video recording of this session, and we appreciate your participation.
Yeah.
So with that,
feel free to reach out to me via email if you have any other questions offline too. You know, this is our, you know, we have a passion for this stuff. So, you know, no question is insignificant as far as we're concerned.
Sounds great. Thanks again, Mike.
All right.
Take
Thanks,
care,
Matt.
everyone.
Thanks, everybody.
Bye-bye now.